Hi everyone, it's Math with AUB. How to find domain of a real valued function. We are discussing in these days how to find domain of a real valued function. Speaking in broad terms, we have to take care of three things. Denominator never ceases. Denominator never be zero. We cannot divide in mathematics by zero. Division with zero is not allowed in mathematics. It's absurd. At higher stages, it is known as indeterminate form. How to deal them? We will see it later. Number two, we cannot afford negative sign in square root. Negative sign in square root means complex valued numbers. Complex valued numbers. And we are familiar, log is defined for positive numbers. Log is defined for positive numbers. Number one, denominator never ever be zero. Number two, in square root we cannot afford overall negative quantity, the negative result. Number three, log is defined for positive values. Let's see and find out our series question number 7. The domain of the function f of x is square root 1 minus square root 1 minus x square. Square root, another square root, another square root. How to negotiate these questions? It's really very simple. In square root, all these square roots are present in numerator. All these square roots are present in numerator. Starting from the innermost square root, 1 minus x square greater than or equal to 0. If it is total equal to 0, we can afford it. We can afford it. In square root, we cannot afford negative value. Solving for x, it will become 1 is greater than or equal to x square. 1 is greater than or equal to x square. This inequality can be written as x square is less than or equal to 1. In order to get rid of this square, it's something like mod x less than or equal to 1. This mod can be written as minus 1 less than or equal to x, and x is less than or equal to 1. This is our closed interval. From minus 1 to positive 1, we can take all the values. One can inspect the situation taking 0. 1 minus 0, 1 minus 0 square is 1. It is a positive value in square root. It is affordable. It is affordable. It is affordable. I have solved this one. Just broad your vision. What about this? Taking this 1 as well and solving for x, we have 1 in square root 1 minus under root 1 minus x square. It must be greater than or equal to 0. Same analogy, same concept. This square root, another square root, they must be greater than or equal to 0. Squaring both sides, we get rid of this uppermost square root. It will become 1 minus under root 1 minus x square greater than or equal to 0. Shuffle this square root here. It will become 1 is greater than or equal to 1 minus x square. Okay. Writing same concept here. Let me repeat it. 1 is greater than or equal to 1 minus x square. Again squaring both sides. 1 is greater than or equal to 1 minus x square. Shift 1 here. Solving for x. 1 minus 1 greater than or equal to minus x square. Cancelled out. 0 is greater than minus x square. Or by multiplying 0, we have x square is less than or equal to 0. X square is less than or equal to 0. X square is less than or equal to 0. Just explore this. X square less than 0. X square is equal to 0. This case is possible. Value of x is 0. It will give us 0. For any real number, when x belongs to or, this is not true. We don't have a real number. We don't have a real number whose square is less than 0, whose square is negative, whose square is negative. However, any complex number satisfies this equation, but we are dealing with real valued function. So x square less than 0 is absurd, inadmissible in our case. It's absurd, inadmissible. So again we stuck to the same interval, minus 1 less than or equal to x, x less than or equal to 1. What about the other one? Let's deal this one. We have manage the show up till 2 square roots. What about third? Let's see and find out. Let's see and find out. We have got one valid interval, that is our -1 is less than or equal to x, x is less than or equal to 1. And second, x square is less than or equal to 0, that cannot be admissible. That cannot be admissible. X square can be 0, but x square can never be less than 0, can never be less than 0, can never be negative. What about this overall statement? Taking same concept, 1 minus under root 1 minus under root 1 minus x square. It must be greater than or equal to 0. Squaring both sides. Squaring both sides, we have got rid of this square, uppermost square root. It will, what remains? 1 minus under root 1 minus x square greater than or equal to 0. Shift this quantity here. 1 is greater than or equal to 1 minus under root 1 minus x square. Again solving for x, again squaring both sides. Again squaring both sides, we have 1 greater than or equal to 1 minus under root 1 minus x square. Shifting 1 here, 1 minus 1 greater than or equal to minus 1 minus x square. Cancelled out. Cancelled out. We have something like 0 is greater than or equal to negative 1 minus x square. Or one can write by multiplying minus 1 minus x square is less than or equal to 0. Again squaring both sides, 1 minus x square is less than or equal to 0. After squaring both sides, 1 is less than or equal to x square. 1 is less than or equal to x square, or we can write x square is greater than or equal to 1. X square is greater than or equal to 1. How to find x? By utilizing mods in the same situation. X mod x is greater than or equal to 1. Mod x is greater than or equal to 1. Mod x is greater than or equal to 1. It means that x, let me draw this, that is -1, 1. From this we can greater than, including x is equal to 1, that is the portion. What about this? That is the portion. Means we have to omit this portion from -1 to 1, from -1 to 1. For this mod x is greater than or equal to 1, it means that x must be less than -1 and x is greater than or equal to 1. For this modulus x is greater than or equal to 1, it can be written as x is less than or equal to -1, x is greater than 1. I have written this. We have to omit that portion. We have to omit that portion. We have to omit that portion. From -1 to 1, we have to get rid of this. From this, we infer that all negative values from -1 towards left hand side, all values from 1 towards right hand side. This is -1 less than x, x is less than 1. This is admissible, 0. This is inadmissible, x square is equal to 0, admissible. What about this? If I put -2 here, it will give me a complex valued function. Any value from here, left hand side of the -1 and also right hand side of the 1 also give me complex valued here. If I take 1.5 R2, it will become 1, 2 square means 4, 1 minus 4 is -3. We cannot afford negative in square root, negative in square root. Taking this in mind and verifying -1 towards left hand side, this inequality -infinity to -1 union 1 to positive infinity. We cannot afford all the any value from this. Greater than 1 can be admissible, greater than 1 cannot be admissible. If I take -2 here, 1 minus 2 square is again 4, it will give me negative values, negative values. So this interval, only this interval satisfied this problem overall. That is the domain of this function. That is the domain of this function. From first tiny part 1 minus x square, we have closed interval from -1 to 1. It gives us a real valued function. Here an anomaly, x square cannot be less than 0. X square cannot be negative. X square cannot be negative in real valued function, in real value numbers, in real numbers, x square never will be negative. And from this inequality overall, taking all square roots, we have to omit from -1 to 1. All values from -1 to 1 we have to omit. We have to omit. We have to take all these values from negative infinity to -1, positive 1 to positive infinity. If I take any number, -2, -3, -4, they give me negative value in square root. Negative value in square root means complex valued function, complex valued function. So our domain of this function is closed interval from -1 to 1. It can also be written as -1 is less than x, x is less than or equal to 1. That is our domain of this function. Moving towards next question, we have